All right, so we have the last part of our component 4. So we've got sine of 2 sine inverse of root 3 over 2. So if you see a problem like this, ask yourself, what would this be? Well, that's on the unit circle, so we could just use our unit circle to answer this question. So where is sine root 3 over 2? Well, sine is root 3 over 2 at 60 degrees, which would be pi over 3. So this gives me sine of, that 2 is still there, and then this whole thing turns into pi over 3. Well, 2 times pi over 3 is like 2 over 1 times pi over 3. So that gives us sine of 2 pi over 3. Well, that's on the unit circle. That's saying what is the sine value at 2 pi over 3? Well, sine at 60 degrees is root 3 over 2. And in the second quadrant, sine is positive. So there's our final answer. Now in number 14, I can't use unit circle because 4 over 5 is not on my unit circle. So whenever we see an inverse, and this is not on the unit circle, we need to use our triangles to help us. So I'm going to draw our triangle. Now cosine is positive 4 over 5 here, so that means we're in quadrant 1. Cosine is x over r. So we know our x is 4 and our r is 5. We know that this is a 3, 4, 5 triangle, or use Pythagorean theorem to figure out that that's a 3. Now that gives us some angle theta. So in this problem, I was able to replace sine inverse with root 3 over 2 with a radian pi over 3. Because that was on a unit circle, I know what this angle is. The angle is 60 degrees. In this problem, I don't know what this angle is, so I'm going to replace it with just a theta. That's telling me it's some angle, but I don't know exactly what angle it is. It could be pi over 7 for all I know. Okay, I'm not really sure. But I still have cosine here, and I still have the 2, and this whole thing turns into theta. Well, cosine of 2 theta, well, let's use our sheet. Cosine of 2 theta is equal to cosine squared minus sine squared. Well, if I look at this triangle, cosine of theta is equal to 4 over 5, and sine of theta is equal to 3 over 5. So if I plug that in, cosine is 4 over 5 squared, sine is 3 over 5 squared, and then let's use our math. So that gives us 16 over 25 minus 9 over 25, which gives us 7 over 25. So this is very similar to part 1 video. The only difference is instead of me saying the cosine is 4 over 5 in quadrant 1, find cosine of 2 theta, I'm just giving you the information in a different way. This is the same thing as me saying given cosine of theta equals 4 over 5 in quadrant 1, find cosine of 2 theta. This and this are the exact same problem, just written in different ways. Okay, so it's asking you the exact same thing, but in 2 different ways. So let's look at another one. Let's look at 15, and then you can try 16 on your own. So on number 15, we have tangent of 2 tangent inverse of 3 over 4. So this is telling us to draw a triangle. Tangent is positive in quadrant 1. Tangent is y over x. So we've got a 3, 4, 5 triangle here. This gives us angle theta. So this is tangent of 2 theta. Now cosine of theta is 4 over 5. Sine of theta is 3 over 5. Tangent of theta is 3 over 4. Tangent of 2 theta. Well, that formula is 2 tangent over 1 minus tangent squared. All I'm using is my formula sheet. All I did was copy it down. Now let's plug it in. Well, we said that tangent was 3 over 4. So this is 2 times 3 over 4 over 1 minus 3 over 4 squared. Well, remember 2 is 2 over 1, so that gives us 6 over 4 all over 1 minus 9 over 16. I can make this one a 16 over 16. The 6 over 4 can simplify to 3 over 2. 16 minus 9 gives us 7 over 16. Well, so far in this step, we've been able to cancel, like these were both 2's. That didn't happen in this problem. So whenever we're dividing fractions, remember that means we're multiplying by the reciprocal. So I'm going to flip this to be 16 over 7, and then I'm going to multiply. So 3 times 16 gives us 48. And then 2 times 7 gives us 14. Well, both of those can simplify. If I divide by 2, I get 24 over 7 as our final answer. Okay, I want you guys to try 16 and then check the answer key.